Want to welcome everyone this afternoon. Representing Albertans concerned over Responsible Resource Development Society, ACORRDS. We're a non-profit society in the province of Alberta. Our objective is to promote responsible energy development in Alberta. Our agenda today, we're going to start with our tremendous speakers on the impacts of fracking. We'll have a short break at 2:45 and let everybody have a look at the tables at the back and have the opportunity to purchase some books if you like. So I will give you our local brilliant young researcher who is Reagan Boychuk, and he will introduce our speakers for this afternoon.
Thank you, Neil, and thanks for all of you joining us here today. It's my privilege to introduce the speakers today, a couple of national treasures in my opinion. Andrew Nikiforuk is one of North America's finest journalists, and he's won many awards in recognition of that, including the Rachel Carson Environmental Book Award. And he's covered the oil industry for decades. And he was among the first to document the impacts of fracking. In his most recent book on Jessica Ernst's plight, Slickwater, won the 2016 Science and Society Journalism Award from the National Association of Science Writers. Andrew is a bastion of knowledge, and he's a tireless advocate for the public good. And as I said before, he's frankly a national treasure. So please welcome Andrew Nikiforuk.
Well, good afternoon, and I first want to thank all of the organizers and folks associated with ACORRD, particularly Neil and Howard and Reagan Boychuk, who is a provincial treasure, I might add, who with Brent Nimick has single-handedly brought to the attention of the Alberta government that they have an outstanding liability in throughout the province in terms of abandoned and inactive wells, a liability greater than $30 billion and not less than $300 billion, and no plan to clean it up. My job today, this afternoon, is to give you a frame and a sense of the impacts of fracking on rural communities, so that when Jessica Ernst tells her story and fills in some of the blanks and explains how things really work in this province, you'll understand what we're talking about. So I want to tell a bunch of stories, and the first story really has to do with this map and the idea that somehow we were all going to get rich and better and improve our lives by blasting apart some of the densest rocks in North America. Rocks as dense as concrete, and the idea was to shatter them to smithereens to release small amounts of oil or gas or natural gas liquids. Now, one of the guys that first jumped on the bandwagon here and said, we're all going to get rich doing this, this is going to be the best thing that has ever happened in the United States, is Audrey McLennan. And Audrey McLennan was the president of Chesapeake Energy, and his story is really the story, the economic story of the Shale Revolution. And his story really illustrates how that the bad economics behind this revolution. So he established a company. They acquired huge amounts of land, and he promised that shale gas was going to become the next affordable alternative. It was going to be the bridge to the future, that there was, 100 years worth of supply, the United States would be energy independent, that, that shale gas and tight oil or shale oil were really, the next best thing. And he made all these promises. And along with all of these promises came a whole bunch of propaganda that was then distributed to rural communities. And so here you have friendly Frackosaurus. Kid you not, this was a coloring book for kids developed by Talisman in Pennsylvania. I'm here to teach you about a clean energy source called natural gas. And here you can see the actual revolution's impact on the landscape, where you are fragmenting and disturbing agricultural lands on a scale we have rarely seen. So the revolution proceeds. Chesapeake's fracks, and they drill. They borrow more and more money to frack and drill, and they, with a whole bunch of other shale revolutionaries, overproduce, flood the market, drive the price of methane down, and with that, their own prospects. And so Chesapeake's Energies, the stock begins to decline, and Audrey McLennan's fortunes begin to decline as he borrows more and more money to keep the treadmill going and the illusion alive that somehow this fracking of shale rock was a profitable enterprise. And was all run by easy credit and originally high prices, which then disappeared. Overproduction of an extreme resource in short periods of time, all made possible by extreme amounts of debt. And in the end, what did Audrey McLennan do? His empire collapsed. He was thrown out of his company. Hundreds of thousands of people had to leave the company. They were unemployed. Company's debt is now 3 times the value of the company itself. He was indicted by the US government for committing fraud on land lease bids. And so one day he got into his SUV, powered of course by shale gas, and drove it into a brick wall. And that was last year. And I think Audrey McLennan's story really epitomizes the economic story behind the fracking of oil and gas formations. It's a bad business. Now, Art Berman, who is a wonderful oil and gas analyst, been in the business for 30, 40 years, puts it very eloquently. He said, oil companies have to make a big deal about shale plays, which McLennan did, because that is all that is left in the world. Let's face it, these are truly awful reservoir rocks. And that is why we waited until all more attractive opportunities were exhausted before developing them. It is completely unreasonable to expect better performance from bad reservoirs than from better reservoirs. And he very eloquently points out that the shale revolution was not really a revolution, but it is a very ugly retirement party for this industry. Now, when I first started working on the book Slick Water, I was trying to come to grips with what this whole story fracking was really about. And I thought initially, well, this is really a story about a brute force technology that has tremendous impacts on energy and capital and the environment, has more consequences associated with it than conventional oil and gas. And I thought, well, but that's not just the story. That's only part of it. And then I thought, well, the story is really about how ugly the resources are becoming. We've used all the stuff at the top of the energy resource triangle, all the cheap stuff. We've consumed it, we've spent it, we've used it, and now we have to move down to the resources that are of the lowest quality. They might be easy to find, They're extremely difficult to develop. They come at very high cost. And in addition to the high cost is just not in terms of capital, it is in terms of high cost to the communities where this technology is taking place. One of the most extreme costs are to the land itself and to the fragmentation of extremely valuable agricultural land. We are destroying a viable, sustainable economy to support an economy with a shelf life of maybe 4 or 5 years. And then I thought, well, maybe this story is really about groundwater contamination from methane as industry fracks more and more wells and can't control the direction of these fracks, and as more and more methane migrates from the ground into the atmosphere or into groundwater or into other well sites or into people's homes. And then I thought, no, well, that's part of it. But what about, maybe this is a public health story, because one of the most extraordinary aspects of fracking are these are industrial sites that have to use an enormous amount of equipment and energy, as well as chemicals and water to crack up these rocks. And the public health studies that have been done are really dramatic. So here's one from Pennsylvania. 35% more cancers in children ages 0 to 4 in fracked counties in Pennsylvania. Young people with leukemia more likely to have lived in areas of oil and gas activities. University of Colorado, 2017. And I could go on for 2 hours quoting the public health impacts of fracking in rural communities. One of the reasons for this is illustrated by this graph. This comes from the Alberta Energy Regulator and their annual report on the flaring of gases from all sources in industry. And you can see that we were working very hard at reducing the amount of stuff we were chucking into the atmosphere. But by 2009, we started to reverse all that, and that almost is all due to fracking. The amount of methane emissions at a fracked site are 3 to 4 times greater than that you would ever see at a conventional well site, which explains why so many people in this community in 2011, 2012, and 2013, when the most intensive fracking was taking place, were not feeling well. We're losing their hair. We're losing all of their energy. We found that they had to actually leave this community and live elsewhere to restore their health. And it's all due to the emissions. And then I thought, well, maybe this story is actually about a criminal legal mechanism to hide abuse. So there are these things called confidentiality agreements, and the oil and gas industry uses them. So does the Catholic Church. When a priest abuses a child, the first thing a bishop will do is will send a lawyer to that family. And that lawyer will negotiate with the family and say, sorry that this happened, but here's a check for $50,000. And then if you sign the confidentiality agreement, you'll get the money, but you'll have to agree to be quiet about this abuse. And the priest will go on to another parish, and we'll all pretend as though this abuse has not happened. And that is exactly how the oil and gas industry has dealt with problems with methane migration, groundwater contamination over the years, where something bad happens, they arrive at the landowner's home with a check, and it's usually a small check, and a confidentiality agreement, and then there is no public record of groundwater contamination. And then I thought, lastly, okay, well, this story is, all right, so it's about a dysfunctional technology, it's about a public health hazard, it's about groundwater contamination, and it's also about methane migration, and it's about aggravating existing problems in the oil patch. So we have all these well sites in North America that we have drilled in the last 150 years. Almost all of them are leaking in either small amounts or in massive amounts. The more we shake up these wells with seismic activity from fracking activity, the more they are leaking. And, you know, a good well site should not be doing this. And yet we're seeing this more and more, not just throughout Alberta, but throughout Texas, in Pennsylvania, in Colorado, in Wyoming, and Oklahoma, and North Dakota. And here's just a map showing the location of well sites that with having extreme amounts of methane leaks. And it's all due to this little thing here. I mean, concrete, once it is cured and seals a well bore, will over time behave like a piece of bubble gum underneath a desk. It will corrode, it will break up, it will crack, and then your well seal will be broken and methane will migrate either into the atmosphere, into other well sites, into somebody's home, or into groundwater. And due to research by Reagan Boychuk and Brent Nimick, we now know how extreme this issue is becoming in Alberta when we begin to add up the number of inactive well sites in the province. And the liabilities they pose, not just in terms of methane pollution, but in terms of liabilities to just cleaning them up to ordinary taxpayer in this province. So fracking then seems connected to so many things then going on in the patch. So in the Western Canadian Sedimentary Basin, we have 500,000 wells alone. We have Maurice Dassault, one of the top petroleum engineers in the business, saying, you know, these wells are leaking. They are a threat to the environment and public safety. And he says the use of enhanced recovery methods, such as steam injection or hydraulic fracturing, elevates the mechanical and thermal loading on the well bores and significantly increases the probability of leakage. So we have a problem that's existing in the patch that's been there for a long time, and that's leaking wells. And we have let this liability grow, and then along comes a brute force technology that is making it worse. And then lastly, I thought, okay, what is this whole story about? And I realized, because slick water is telling the story of fracking through the story of Jessica Ernst. And Jessica's story is fundamentally a story about the courage of women and what women will do when they see their community and they see the health of women and children in their community being put at risk. And I just wanted to read something here from a little book called On Tyranny by Timothy Snyder. He was an historian from Yale University. And he just writes about the character of the age today and the importance of standing out. And this is what Jessica Ernst has done at great personal cost to herself. He says, somebody has to. It is easy to follow along. It can feel strange to do or say something different. But without that unease, there is no freedom. Remember Rosa Parks. The moment you set an example, the spell of the status quo is broken, and others will follow. And that is what Jessica has done for this province. Now, a few more words on fracking so you have the full picture here. So fracking is not something new. It's been going on for a long time, and it started as early in the 1850s and 1860s in the very first oil field in North America, and that was in Pennsylvania. And the first thing that drillers found out was that you might have a well and you might be producing 10 barrels a day, but within a year or within 6 months you were down to 2 or 3 barrels a day, and you were dealing with the reality of depletion, and the only way to beat that reality was with a contraption developed by a Civil War general called an explosive torpedo, which you would put down your wellbore, run like hell away from it, and blow the thing to smithereens and hope that you have opened up new fractures and restored some production to your well site. And Colonel Roberts was really the father of fracking, and also the father of the most litigation ever seen in the United States. And he established a tradition to this day that has made the oil and gas industry one of the most litigious. So fracking evolved from torpedoes and nitroglycerin and to eventually to fluid injection, so sending down massive amounts of fluid. But really, by the 1950s, it wasn't massive. It was very modest amounts. And the fluid was not water. It was, in most cases, diesel or napalm or gasoline. And you might throw in a couple of nails and some sand to help keep those fractures open once you've sent all this stuff down the wellbore. And here's what a modest operation looked like in 1955. And of course, everyone at that time was, dealing with the depletion as well, and you would, frack it up. And then, of course, you're never satisfied with a simple frack. I mean, scientists came up with the idea, well, why don't we really nuke a formation? That'll be the mother of all fracks. They did this in Colorado, only to discover there was no market for radioactive gas. Funny thing about that. And now you come to the evolution of this brute force technology to kind of operations you typically see in northern Alberta and northern BC, where by around 2005 at least, you were using 5 million gallons per frac and using up to 61,000 horsepower to pressurize it and get it into the ground. And so fracking, you can say, started out on a very small scale, in terms of technology, it was equivalent to something like a canoe, and now it really looks today like a nuclear submarine in terms of its impact, in terms of its force, in terms of the energy, in terms of the capital, and in terms of the complexity that the industry cannot control. And then you come to the issue of water, and from the very beginning, fracking has always contaminated groundwater because industry cannot control the direction of all of its fracks. So here's Norman J. Hine. He is one of the, again, top petroleum geologists. He's written a book that's used by the industry for teaching folks about how the industry works. And he says a well can be fracked several times during its lifetime, and in some instances, however, hydraulic fracturing can harm a well by fracking into water. The hydraulically induced fractures extend vertically into a water reservoir that floods the well with water. You look at all of the early patents on fracking, even right up to this day, and they all talk about this persistent problem of fracking into water zones. And then we have the US government documenting this very reality in a report that was published in 1987, no less, by the Environmental Protection Agency. And here they put it this way. During the fracturing process, fractures can be produced, allowing migration of native brine, fracturing fluid, and hydrocarbons from the oil or gas well to a nearby water well. When this happens, the water well can be permanently damaged and a new well must be drilled or an alternative source of drinking water found. And on top of it, the report adds, we do not know how bad this problem is because of all of these confidentiality agreements that have been signed and have kept record of groundwater abuse off the public record. 1987. Federal government report, the United States. Here we are in Alberta, 2017, and our government can still not admit what the federal government was discussing in the United States in 1987. Here's industry admitting, whoa, we've got some problems. 70% of unconventional wells in the United States do not reach their production targets. So where the hell are those fractures going if they're not reaching reaching the production targets. 60% of all fracture stages are ineffective. And 73% of the operators are saying, we don't know what's in the subsurface. In other words, we don't know where all the natural faults are. This is Baker Hughes, by the way, that's making all of this information. All right, so what about fluid injection? What do we know about fluid injection? So we know that, yes, we can contaminate groundwater sources from fracking. What about earthquakes? Can we cause earthquakes with fluid injection? Well, the U.S. Army proved this in the 1960s when they had a whole bunch of chemical waste at the Rocky Mountain Arsenal just outside of Denver, and they started to inject it 2 to 3 miles underneath the ground. And they said, man, we've got this stockpile, and it's you know, corroding the barrels it's being stored in. Let's dump it into the good earth. And so they injected over a 4-year period 165 million gallons into the ground. Now, I want you to think about that figure, 165 million gallons. There was a frack job in 2015 in northeastern British Columbia that used 45 million gallons of water. And it caused a 4.6 earthquake, which I'll talk about later. So this amount of fluid going into the ground over 4-year periods, what did the U.S. Army do? They triggered 1,300 earthquakes over this 4-year period, resulting in a 5.3 magnitude earthquake outside of Denver, causing tens of millions of dollars worth of damage, proving that you cannot control the seismic activity that you have triggered from fluid injection. Then we have the United States Geological Survey, one of the top scientific bodies in the United States. They came out with a report in 1990, Earthquake Hazards Associated with Deep Well Injection. This is the first reference I came across to that documented that early hydraulic fracturing, and they were massive fracks, in Oklahoma were triggering up to 70 earthquakes a day in 1978. And we have people in the industry and among regulators in this province who are still disputing the fact that hydraulic fracturing can cause earthquakes. These scientists furthermore made this point. The occurrence of small earthquakes near the bottom of a deep injection well you have various forms of fluid injection, right? You can be disposing of wastewater, or you can be sending a whole bunch of water down the wellbore to break rocks open, and that's fracking. So the occurrence of small earthquakes near the bottom of a deep injection well may indicate faulting or fracturing processes that conceivably could lead to a breach in the overlying confining zone, and therefore conceivably could permit hazardous materials to migrate upward toward potential drinking water supplies. And sure enough, as the more we have fracked, and the more wastewater we have generated, and the more disposal wells we have used, the more we have changed seismic patterns throughout North America, beginning in Arkansas, Oklahoma, Texas, and Colorado. The number of magnitude 3 earthquakes has just grown exponentially, resulting in magnitude 5 earthquakes in Oklahoma, causing significant damage to public infrastructure. Here's what's been going on in northern Alberta and northern BC. This is from a video presentation by a group of researchers that have been tracking the incidence of earthquakes as industry has fracked more and more. And by the way, about 90% or 95% of all oil and gas wells today are being fracked. So if you can see the chart at the top, you see the count of hydraulic fracked wells. As it increases, the earthquake count is increasing and increasing. The black dots, that's the fracking. The red dots are magnitude 3 earthquakes or greater. In British Columbia alone, since 2006, the industry has triggered more than 1,000 earthquakes. In Alberta, we're somewhere between 1,000 to 2,000 earthquakes. And I mentioned that the fact that we are now fracking with up to 45 million gallons of water in both Alberta and BC, and that's 3 to 4 times more water than is used in average frac jobs in the United States. So it's no wonder that fracking here is causing more earthquakes. And so Progress Energy caused a megaquake in 4.6. A mega fracking operation caused a quake of 4.6 magnitude. That was in 2015. Of course, the industry, the company said, well, probably we're not responsible for this. It was probably natural activity. Well, that has all been proven to be a lie. And researchers have now come out and said, the ground motion from that event, which could be felt 120 kilometers away, and it occurred about 100 kilometers north of Fort St. John, the ground motion from this event could have exceeded the damage threshold of structures if it had happened in a populated area. In other words, if it had happened closer to Fort St. John, it would have caused an extreme amount of damage to public infrastructure, including homes and streets and gas lines and water lines. We've had the same issues in Alberta with growing magnitude of earthquakes in Fox Creek 4.8. Again, what are the scientists saying? Well, major challenges exist in understanding the relationship between injection volume, rate, and reservoir pressure, and induced seismicity, as well as how to identify critically stressed faults. This is a polite way of saying we are conducting a scientific experiment in rural areas in northern BC and Alberta. What are the regulators saying? This is the Oil and Gas Commission in BC. You won't find this kind of admission here in Alberta yet. Yeah, we're concerned about ground motion, public safety, property damage, wellbore integrity, casing deformation, reservoir breakthrough, aquifer contamination. And of course, this did not appear on a public site in British Columbia, but appeared only in a presentation to a select audience at a scientific conference, I believe, in Montreal. So the regulators are saying, well, maybe we can control all of this earthquake activity if we come up with a traffic system. Like, well, we'll have a red light and a green light, and you can frack if the light is green, and you better stop fracking if the light is red. And most of the experts that I've talked to said, look, this is ridiculous. We know how to start earthquakes, but we are still far from being able to keep them under control. And in the process of all these earthquakes, all this seismic activity, we are increasing migration of gases from the Earth. We know that the more you shake up the Earth, the more pathways you create for gases to move in the Earth. The Earth is always breathing, is always releasing some kind of gas, whether it's radon, whether it's CO2, whether it's methane. But the more you shake and frack that Earth up, the more pathways you create to the surface. Good example, in the Four Corners in the United States, where some of the most intensive fracking of coal seams occurred in the 1980s and 1990s. They now have a methane plume over the Four Corners the size of the state of Connecticut that represents 10% of the methane emissions from the United States. That's astounding. And we know that because NASA caught it, this anomaly, on their satellite imagery. Now, I imagine if you did satellite imagery in Alberta and in northeastern BC, in the Horseshoe Canyon and in the Duvernay Formation and the Montney Formation, you might find something similar to these this kind of methane anomaly in the United States. But we don't do that here. Here's again one of the top experts in the business. Seismic activity can create faults and fractures, and seismic vibrations can increase permeability and upward gas migration. And that is what fracking does. This brings me now to Jessica Ernst, who has worked in the oil patch all of her life. She is not an environmental activist. She is a concerned citizen, and she found herself in the odd position of living in a community where the industry that she worked for came in and started to secretly frack the coal seams without telling people what they were doing or why they were doing it. She has worked in the industry for more than 20 years. She's worked for some of the biggest companies, everybody from Murphy Oil to EnCana, the great North American oil sands company. Here she is even on the cover of the Oil and Gas Journal. A respected environmental scientist who looked at cumulative effects, who dealt with First Nations, who looked at the impact of pipelines, and her goal was to reduce all these impacts. Here comes industry with a plan to carpet bomb, that is their word, to carpet bomb the agricultural communities between Calgary and Edmonton in the Horseshoe Canyon, which is where a coal seam, and more than 10,000 wells were drilled over a space of a decade. And even Schlumberger later admitted, well, you know, this could be a real problem, fracking coal, already a pretty fractious material because a lot of groundwater moves through coal. Because of the shallow depth of many CBM basins, the potential exists for a fracture growing out of zone and affecting freshwater aquifers, and we could add here, and contaminating them with methane. And that's exactly what happened in central Alberta, where you can see the greatest concentration of groundwater wells and dependence on groundwater wells in the province, the same area that got fracked to death about a decade ago. And Jessica Ernst, her story exemplifies all of these other issues. The more you frack, the more you disturb other existing oil and gas infrastructure. So here are all the red dots here those are the gas wells fracked into freshwater zones in Rosebud around April 2006. And the small black dots represent conventional and deeper fracked wells. And you know there's going to be interconnection between all of these because of all the immense amount of brute force taking place. And that's exactly what she experienced as her water became grossly contaminated with explosive amounts of methane such that she could light it on fire. This is just an illustration from EnCana showing how they fracked directly into a zone where very shallow, about 125 meters, and the frack went right into the groundwater and contaminated the groundwater for at least a dozen landowners living in a river bottom of the Rosebud River. And so I thought, okay, well, has this happened before where you have fracking in an uplands and you've got people living in the lowlands and the fracks are coming down here and then they're shooting out into the groundwater and then people living in the river bottom, they're finding all their groundwater contaminated with nitrogen, foam, or methane or something else. And sure enough, God damn it, going back 1980s, there are reports of this very same phenomenon taking place in Pennsylvania. Same illustration. Frack job that has gone bad, the frack has gone out of zone, and people here could light their well water on fire. In Jess's story, she found a company that used to be her chief client, had fracked into a local aquifer. The energy regulator then falsely branded Ernst a criminal threat. Alberta Environment then conducted a bogus water investigation, and then the Alberta Research Council covered up government fraud. Her case has now been in the courts for 10 years, 11 years. Tony Ingraffia, one of the world's foremost experts on the fracking of rocks and the science of fracking on rocks, and he calls it a chaotic activity because you do not know, again, where all these fracks will go. He says, Jessica Ernst's case is significant for these reasons. because she's proposing to break the cycle of abuse in rural communities. Industry's always said, 1, we didn't do it. 2, why don't you prove it? 3, silence. Maybe we did, but we're not going to tell anybody. And Jessica has caught them all in the act and exposed it. Number 1, she caught the industry doing it. Number 2, as Tony says, she's got the evidence to prove it. And number 3, she won't be silent. She will not sign that confidentiality agreement. Meanwhile, this experience of abuse you can find across North America. Go to Pennsylvania, where you'll find somewhere between 200 and 300 cases of groundwater contamination directly related to hydraulic fracturing of shale in that state. Not only that, it took 6 years, it took a newspaper 6 years in the courts to get this information released to the public. If you go to Colorado, where again you can see 1991, the density of wells around Greeley was small. With fracking, we have increased the density in an extraordinary way, with the result that as well density increases, again, this is industry admission, it becomes increasingly probable that wells will communicate either through previously created fractures or through adjacent well bores and then into previously created fractures. And when that happens, you sometimes have kabooms. And this kaboom happened about a month ago outside of Denver, and 2 people died in this house. And Anadarko had to shut down 3,000 wells because they had a gas migration problem that killed people. Does gas migration happen in Alberta? Sure it does. Here's a pump well house from central Alberta owned by Bruce Jack. He was in there checking it with 2 other employees, and they were blown the hell. Bruce Jack himself was blown 70 feet from the pump house. There he is in hospital. Have you read or heard about this story in Alberta? No. It was investigated. It was proven that industry was responsible for this gas migration. Alberta Innovates will not release these documents. There was a quick investigation in Colorado, and they said, yes, industry caused this gas migration. Here in Alberta, there was an investigation, but the government will not release it, will not admit that gas migration is a problem in a province with more than 500,000 wells. And here, just to prove it, there's a document that the Alberta Energy Regulator commissioned last year. It has not been released. I have a copy of it. I'll be writing about it shortly. It's about toxic methane exposures in the province. And so they're defining a toxic exposure as more than 10,000 parts per million. And they're saying, if there's that amount of methane in the atmosphere, you should get the hell out of there because it's highly explosive. And they're saying, even exposures of 1,000 will have neurological effects because methane doesn't travel alone. It travels with other gases, including benzene and butane and radon. And so here's their data. They looked at 1,500 urban wells. They took, and there are 1,500 abandoned wells, in urban places in Alberta. So they are in Edmonton, they are in Medicine Hat, they are in a number of cities. So they've done some testing on about 300 of them. And of those 300 wells, they found that 36 were leaking extraordinary amounts of methane. And then they broke that down and they took out 9, and they found 9 here have the worst amounts of methane. 100,000 parts per million. That 10 times is greater than what Alberta Health is saying you should run for your life. And these are near churches and playgrounds in urban Alberta. My last story. So you think, okay, surely Alberta is not the only place where all of this is happening. Surely it is not. Australia, Bed Methane. The same story, big boom, no cumulative impact studies. But a massive number of people stood up and said, you cannot do this to our agricultural land. You cannot do this to our groundwater. And industry and government pressed on. This is what they turned some of the best farmland in Australia into this. And then some scientists did some studies, and guess what they found? All right, so this is what the kind of landscape looked like, and you can see where the water table is and the coal seam. And then they go in there and they frack like hell. And so these guys went with a machine, they put it on a truck, and they drove through an area that wasn't being fracked, and they were measuring for methane and CO2 and radon, and they didn't find anything in the air. I mean, very small amounts. And then they went through an area that was being intensely fracked, and they found 3 times more methane, CO2, and radon in the atmosphere, proving once again that hydraulic fracturing works like seismic activity and releases more gases into the atmosphere. My final point, I think, says it all. We can begin investing in renewables, or we can frack Alberta's landscape like hell. It seems to me obvious what we should begin doing. And I think it is also important to remember that we become civilized only by knowing what to refrain from doing. Thank you.